Hello guys and welcome to today's video. We are going to be solving a random question in statistics and it goes like this. So given the frequency distribution table below, use it to answer questions 6 to 11. So you have the table and you have your grouped data and you have frequencies associated with each class. Then question 6 says, what is the lower class boundary of the lower quartile? Question 7, what is the value of the lower quartile? Question 8, what is the lower class boundary of the upper quartile? Wow. Question 9, what is the value of the upper quartile? And 10 is what is the interquartile range? And 11 is what is the semi-interquartile range? So all these terminologies might be looking strange to you, but you can trust that at the end of this class you will understand what each and every one of them mean, and in case you've learned about them before but you forgot, you're going to be refreshed in this class. If you're just joining this class for the first time, this is my channel, Make Me a Solution, and I would like you to support this channel by subscribing and liking my videos, and you can check out my playlist to see the videos that I have published and the ones that I will be publishing in engineering mathematics, statistics, probability, and mathematics in general. So let's dive in, and I hope you have fun during the course of this video. So let's begin. So the first thing you need to do when you're given a question like this is to prepare a quick table. So I just prepared the table, and that table should contain the following columns for this kind of questions. Any question concerning first quartile or upper quartile or lower quartile, all those kind of questions. It's very important that you prepare this table, and it should have a cumulative frequency column. Now, if you're dealing with a grouped data and ungrouped data, or sorry, let's start with grouped data, such as the one that has something like 0 to 2, 3 to 5, and so on and so forth. Make sure you prepare a class boundary column. Okay, so the class boundaries, remember, it's gotten by subtracting and adding a particular value to the lower class limit and upper class limit. The value that you subtract and add can be gotten by taking the difference between the lower limit, the upper limit of one class, and the lower limit of one class and the upper limit of the class preceding it. That's 3 minus 2 is 1, and 1 divided by 2 is 0.5. So that is going to be the value that you will add to the upper limit and subtract from the lower limit. 0 minus 0.5 is going to give you negative 0.5, and 2 plus 0.5 is 2.5. So you continue from 2.5, and you're going to add 0.5 to 5, giving you 5.5. So we're going to continue to populate all this place. So you have 5.5 to 8.5, 8.5 to 11.5, 11.5 to 14.5, 14.5 to 17.5, 17.5 to 20.5, and 20.5 to 23.5. Okay, so you have it like this. This is your class boundary. I hope you know how to find class boundary very well. Now, the next is cumulative frequency. To get cumulative frequency, you start with 1, and 1 plus, this is 2, okay? 1 plus 2 is 3, 3 plus 2 is 5, okay? So this is 2, then 5 plus 3 is 8, 8 plus 6 is 14, 14 plus 3 is 17, 17 plus 2 is 19, and 19 plus 1 is 20. The last value of your cumulative frequency tells us the total number of data entries we have, or you can find n by taking the sum of the frequencies, which is 1 plus 2, 3 plus 2, 5. It's just basically repetition of what you did here, and you're going to get 20 at the end of the day. Is that okay? So your frequency or your data entry is 20 data entries, and your cumulative frequency gives the position of data entries. I'll still explain that very soon. Now that you've gotten your table, the next thing you need to do is to dive into the question. The first question is, what is the lower class boundary of the lower quartile? So there are two questions, or two statements we need to analyze in question 6. Lower class boundary of lower quartile. Now, to get the lower class boundary of the lower quartile, you need to find the position of the lower quartile. So what did I say? Find the position of the lower quartile. If you find the position of the lower quartile, you'll be able to find the lower class boundary of the lower quartile value. So the first thing is determine the position of lower quartile. Mathematically, the lower quartile is designated as Q1. The lower quartile is also known as the first quartile. They all have the symbol of Q1. Okay, and if you want to find the position of the lower quartile, the position of the lower quartile is the n plus 1 all over 4th position. Okay, the n plus 1 over 4th position or term. So if we can get the data entry that is situated in the n plus 1 over 4th position, then we'll be able to track the lower class boundary. Okay, so the first quartile or the lower quartile is the data entry at the n plus 1 over 4th position. Now, let me just quickly tell you something. Whenever you're dealing with odd n, when your total number of data entries is odd, you just simply use n plus 1 over, you just use n over 4, okay, n over 4th term. But when you're dealing with even n, you use n plus 1 over 4 term. So this will apply to your median and to your upper quartile or to your third quartile. Is that okay? So we are going to get to that. So when we are dealing with odd, we use just n over 4, but when we are dealing with even, we use n plus 1 over 4th term. It is important to use this n plus 1 over 4th term. And I'm using n plus 1 over 4th term because my n is equal to 20 and this is even. So let's quickly find the position of the first quartile so that we can find the lower class boundary. So the first quartile is located at 20 plus 1 over 4th position, which gives me 21 over 4th position, which gives me that the first quartile Q1 is what? Very good. 21 divided by 4 is 5.25 position. So Q1 is at the 5.25th position. So the 5.25 position is contained in the class. Okay, so let's find the class that contains the 5.25th position or the 5.25th term. Okay, so this is how we'll get it. Now, if you want to find the 5.25th data entry, or you want to find the class where the 5.25th data entry is, the 5.25th data entry or position, you need to thoroughly understand the role of this cumulative frequency column. Let me explain it very quickly to us. Cumulative frequency tells us that, okay, the first designation is 1. It means that the first data entry is here. Now, the second designation is 3. What does it mean? Starting or continuing from 1, I'll go to 3. So the second and the third entry is in this class. So the first entry is in this class. The second and third entry is in a class whose cumulative frequency is 3. How about a class whose cumulative frequency is 5? Continuing from 3, you have 4 and 5. So the 4th and the 5th data entry, or the 4th positions and the 5th positions, is actually going to rest in this class. How about a class whose cumulative frequency is 8? If you continue from 5, you will have to count 6, 7, and 8. So you count from the 10 immediately below, above this one, okay, to the absolute value of this one, so 6, 7, and 8. So it means that the 6, the 7, and the 8 terms are actually what? Resting in this class whose cumulative frequency is 8. So doing the same thing for 14, you agree with me that 9, 10, 11, 12, 13, and 14. So from 9th position to 14th position are in this class. So the 9th data, the 10th data, 11th data, 12 up to the 14th data are in this class. Okay, so when we have a cumulative frequency of 17, what does it mean? It means that the 15th, that I'm continuing from this one, 15, 16, 17. So 15 data, 16, and data 17 are in this class. Now for 19, if I continue from 17, I'll get 18 and 19. So it means that data 18 and data 19 are in this class. Then 20 from 19, we'll just have 20. 20 in this class. So data 1 or the first position is here, data 2 and 3 is here, 4 and 5 is here, 6, 7, 8, and so on and so forth. Now, if you compare these datas against the frequency, you will see that they are the same. Like the data 1 is occupying first position and having only a frequency of 1. Then data 2 and data 3, okay, meaning that we have 2 entries. So we have 2. 4 and 5 is also 2 entries. We have 2. 6, 7, 8 is 3 entries. 9, 10, 11, 12, 13, 14 is 6 entries. 15, 16, 17 is 3 entries. 18, 19, 2 entries. 20 is 1 entry. So this is cumulative frequency. It helps us to understand the position where each data is. So this is position, okay, of each data. Now, if you want to find the data in the 5.25th position, I'll ask myself, in which of the following classes will I find the 5.25 position? I can only find up to the 5th position at this particular class. Okay? I cannot find anything beyond the 5th position. So since this one is 5.25, I will not take this class as my lower quartile class. Rather, you extend it to this class. Okay, so this class contains 6, 7, 8, and 9. And take note, this 6 I wrote here, I was just trying to tell you all data from the biggest value immediately after 5. The biggest value immediately after 5. That's what this 6 means. So everything from the biggest value immediately after 5 to 8. So this one stops at 5. You can't go beyond 5. That's why I'm not going to use this class. No, this is not the lower quartile class, but rather, since 5.25 is contained in this class, remember what I said about this 6. This 6 that you're seeing here is actually all values that are immediately greater than 5, okay, down to 8. That is what it means. So all positions of data from the first one after 5 to this particular value 8 is resting in this class. So whenever you calculate your Q1 and it gives you 5.25, it means that you're going to choose this class as your Q1 class. So this will be designated our Q1 class. So this is our lower quartile class, okay, our lower quartile class. So if this is the lower quartile class, you can now easily identify the lower class boundary. Is that okay? So the 5.25 position is contained in the class 8.5 to 11.5, as we can see it up here. So it is contained in this class. Then the lower class boundary of that class, LCB of, okay, lower quartile. Why am I calling it lower quartile class? Because lower quartile class is at this position, okay, and the lower class boundary is what? 8.5. So the answer to this question is 8.5. Is that okay? So the answer to question number 6 is 8.5. The lower class boundary of the lower quartile is 8.5. So let's proceed to finding the value of the lower quartile itself. So I hope we are still together. So let's find the value of the lower quartile. So remember, all we just did, all I was just trying to explain to you is how to use this particular formula and blend it with cumulative frequency so that you can determine the position of any particular quartile you want. You want to make sure that you know the class that the lower quartile belongs to. Now, this value that we found, 5.25, is not the lower quartile. It is just the position of the lower quartile. If you now want to find the lower quartile itself, you have to use the formula Q1 is equal to lower class boundary of the lower quartile, that's LCB Q1. I'll use Q1 to designate lower quartile, plus I'll use n over 4 because the lower quartile is a quartile of your data, minus cumulative frequency before the lower quartile class divided by the frequency of the lower quartile class and everything multiplied by class width. So this is a pattern of formula that you will use to find your lower quartile. Now let's use our table to interpret what this will be. Before you use this formula, it is expected that you already know the class of your lower quartile. And from the previous question, we were able to get the class of the lower quartile using the n plus 1 over 4th position, okay, to identify the position of the lower quartile. Now you use n plus 1 over 4 here, but you're going to use n over 4 here, okay, both for odd and for even, okay. So it's good that we use it like this. Now let's find the lower class boundary of the first quartile, which is an 8.5, then plus n over 4, 20 over 4, minus cumulative frequency before the lower quartile class. Now this is the lower quartile class, everything here, okay. Now this is the cumulative frequency of the lower quartile class, but this is the cumulative frequency before, which is 5. Is that okay? So you put 5 divided by frequency of the lower quartile class. Frequency of the lower quartile class is given to us as number 3, okay. Then class width. So class width W is going to be what? How do we calculate class width? Class width is calculated by upper class limit minus lower class limit plus 1. So any of the upper class limits and lower class limits plus 1. 14 minus 12 is 2 plus 1, 3. There's another way to calculate your class width by taking the difference between the upper class boundary of one class and the upper class boundary of the class preceding it. So 8.5 minus 5.5 will also give you 3, or 17.5 minus 14.5, or 23.5 minus 20.5 will give you 3. Okay, so when you're using class limits, upper limit minus lower limit plus 1, when you're using class boundary, you use the class boundary of one class, upper class boundary of one class minus upper class boundary of the class before it, or lower class boundary of one class minus the lower class boundary of the class before it, and to still give you 3. So since our class width is uniform, we will take W as 3 throughout the course of our solving, times 3. So when we evaluate, we'll have 8.5 plus 20 divided by 4 is 5. 5 minus 5 is 0. So 0 over 1. So this just means that our Q1 is 8.5 plus 0, which is 8.5. So the exact value of the first quartile or the lower quartile is 8.5. Okay, so we couldn't have gotten this value had it been we never knew the class of the lower quartile. So first things first is, before you use this formula, identify the class where your lower quartile belongs to, okay, which you can do using this formula pattern. So from this point on, I'm going to be super fast so that we can finish the rest of the question, okay, on time. So number 7 is 8.5, which you have here. Number 7 is 8.5. So the value of the lower quartile is 8.5. Then next question is, what's the value, okay, or what's the lower class boundary of the upper quartile? So the same thing, lower class boundary of upper quartile. So number 8 says lower class boundary of upper quartile. To find the lower class boundary of the upper quartile, you need to find the position of the upper quartile, which is Q3. Okay, upper quartile is also known as third quartile. That's Q3. Now, Q3, if you want to find the position of Q3, so Q3 is at the 3 bracket n plus 1 all over 4th position, okay, or term. So solving, we have Q3 is at you have 3 into n plus 1 over 4, which is 20 plus 1 all over 4th position. And if we evaluate this, we are going to get 21 over 4 is 5.25 times 3 is going to give me 15.75, okay, position. So the third quartile is on the 15.75 position. So I'll now ask myself, the 15.75th position is in class. So the 15.75 position, or the 15.75 term, so where is the 15.75 term lying? So you can follow your cumulative frequency column to find it out. So you can see that this is 9, 10, 11, 12, 13, 14, while this is 15, 16, 17. So position 15, 16, 17 are lying in this particular class. So since this is 15 and 16, you know that 15.75 position is actually between 15 and 16. So all of them are engrossed in this class having a cumulative frequency of 17. We can now conclude that this is my Q3 class, or this class belongs to what? Our what? Upper quartile. So the upper quartile class is a class whose cumulative frequency is 17. Okay, of course it contains this 15 immediately because this 14 does not contain it. You take note of the positions. So the frequency of the upper quartile class is 3. The upper class boundary is 17.5 and the lower class boundary is 14.5. So we have 14.5 to 17.5. So the 15th position, or the 15th term, is contained in the class 14.5 to 17.5. Therefore, the lower class boundary is actually going to be what? 14.5. So this is the lower class boundary of the class that we are interested in, which is the lower class boundary of the upper quartile. Lower class boundary of the upper quartile, 14.5. Okay, so let's look at question 9. Find the value of the upper quartile. So we now want to find the value itself. So remember, there is a difference between calculating the position of the upper quartile and calculating the value of the upper quartile. So in question 9, we want to find the upper quartile. So we are still going to use the same pattern of formula. Q3 is going to be lower class boundary of upper quartile class plus 3n/4, 3/4 of the data, that's our upper quartile, then minus cumulative frequency before the third quartile class. And we now have the frequency of the third quartile class, FQ3, and you now have times class width, W. Is that okay? So let's read off all these values. We have established that our third quartile class should be this class. That's the class having 14.5 to 17.5. So the next question is, we have the frequency of this class as 3. Okay, now what is the cumulative frequency before this class? The cumulative frequency before this class is clearly 14. Is that okay? The frequency of this class is 3, and the class width is the same as 3. So we can just plug in all these values. Lower class boundary is 14.5, then plus we have 3n/4, that's 3 times 20, 60 divided by 4, 15, minus cumulative frequency before this class was 14, divided by the frequency of this class we got was 3, and the class width was 3. Okay, so when you cancel 3 out, you get 14.5 plus 15 minus 14 divided by 1 is 1, and you have 15.5. So that is the value of your third quartile. So the exact value of your third quartile is what? 15.5. Whereas the exact value is 15.5, the position of this third quartile is the 15.75th position of our data, and the lower class boundary of the upper quartile is 14.5. So take note of the difference between the position, the lower class boundary, and the exact value of the upper quartile itself. So 15.5. So let's see what question number 10 is all about. So question number 9 is 15.5. That's the value of the upper quartile. So what is the interquartile range in question 10, and what is the semi-interquartile range in question 11? So let's just take two of them at once. So question 10 tells us what is the interquartile range, IQR. IQR is taken as the difference between Q3 and Q1. So your value of Q3 minus your value of Q1, your upper quartile minus your lower quartile, or your third quartile minus your first quartile, which is 15.5 minus 8.5, which is 7. Then Number 11, your semi-interquartile range is giving us what? Your semi-interquartile range is going to be giving us your Q3 minus Q1 divided by 2, okay? Half of the interquartile range, which is 7 all over 2, eventually that's 3.5. So the value of our interquartile range is 7, and the value of our semi-interquartile range is 3.5. So that's it. The value of your interquartile range is 7, the value of your semi-interquartile range is 3.5. So this brings us to the end of this video practically, but I just wanted to show you something very briefly. What if you're asked to find median? Okay, I want you to verify something, students to verify. Now you can find median Q2 by saying lower class boundary LCB of your median class as LCB Q2 plus, this time around to be n over 2 halfway up the data for median, then minus cumulative frequency before your median class divided by frequency of your median class, and everything multiplied by class width W. So if you have followed this video very well, I want you to try to find the median. So the median value Q2, the median is at the position n plus 1 all over 2, okay? The n plus 1 all over 2's position. So from this position, you'll be able to evaluate the class that contains the median. That's by finding the lower class boundary of that class. You'll be able to find the cumulative frequency before that class. You'll be able to find the frequency of that class. N over 2 is just 20 over 2 since n is 20. And when you add all these values, you should be able to find your median. But what I want you to verify is to verify whether when you solve this thing like this, you still get the same as Q3 plus Q1 all over 2. So are these the same? Are they the same? Is Q2 equal to Q3 plus Q1 all over 2? So I want you to verify. So verify and put your answers in the comment section, and I'll see who gets it, or I'll definitely react to your comments. So I hope you enjoyed this video. I hope it was explanatory to the point where you understand and to the point where you can reproduce in exam or test scenarios. So this is statistics, and we are learning how to calculate some data beyond just the measures of our central tendency, mean, mode, and median. We are deviating into calculating lower quartiles and upper quartiles, okay? And maybe you can also use this pattern to solve for percentiles and decals, etc. in any statistics data. So if you want to learn more about the statistics, you could make sure you subscribe to my channel, and you can ask me questions, ask me to make a video on so particular subjects, and I'll be willing to help with that. And till the next video, stay tuned, stay informed, and stay blessed. Bye.